Okay, Math 2, we're looking at simplifying radicals. This time we're going to get a little more challenging. We got cubes and variables that we're going to show up with. So the first thing I remind you of what it is to be a cube. If you have an integer cube, of course cube means third power. So we're talking about something raised to the third power. We call those perfect cubes. So here's a couple examples of our perfect cubes. Of course 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So you guys take a few minutes, you fill out that list. That's the first 10 perfect cubes. Now, the deal with perfect cubes is you don't need, they're hard to remember, all right? A lot of people have a hard time knowing these. Personally, I know 8 and 27, I recognize 64 and 125, but after that, I don't pay attention to it that much, so we don't have a lot of these memorized. But anyways, we're going to do our simplifying radicals the same way we did yesterday. We're going to do this method 1 prime factorization. It works out really well. Okay. First thing I notice is this time it is a cubed root. That's a third power right there, a third index. So because that index is a 3, what we're going to be doing is we're still going to do the prime factors. And then yesterday we would look for groups of 2, pairs. Well, now because the index is 3, we're going to do groups of 3. That's what we're looking for. And that's the only difference. Okay? So there's one group of 3. You see it right there. It's the 2. So that goes on the outside. And the leftover goes on the inside. So that extra 3 right there goes on the inside. And then just, of course, pay real close attention. That's not a square root sign. That's a third root sign. So this time, whatever the index is how many groups we're looking to circle. So let's go with the 54. And now we're looking for groups of 3 because the index is a 3. And you can see there's a group of 3. And we have the 2 left over, so the 2 goes on the inside. Again, we got a third power, so we're looking for groups of 3. Well, that's nice. Look at that. That was a perfect cube, wasn't it? Okay, if I would have looked up here on my list, I would have recognized it. So now, how we do with the variables? I've got 5 x's, right? Well, I'm still doing the same thing. Groups of 3. So there is one group of 3. So I put the 2 and 1x, because it's one group of 3. And then those 2 leftovers right there are going to go on the inside as x squared. Try that again with the 16. You can see I have one group of 2, so there's that 2. And I put the leftover 2 on the inside. Now I deal with the a's. You can see this time I had 2 groups of a's, so I put a squared, and that 1a right there goes on the inside. That's the idea. All right. Method 2, I'm not even going to go over. I'll show you one example with it. I'm not going to talk about it much, though. In order to do method 2, you've got to understand and know your perfect cubes. So I recognize that 8 was a perfect cube up on that top list. And then I just simplified it down. But I'm not going to do any more that way because it's a much harder way. If you want some help on that individually, I'll be glad to help you. All right. We're going to look at some other roots here. Start off with my prime factors. And this time I made a group of 4. Why did I make a group of 4? Because the index was a 4. So as you can see, guys, the index tells you how to make your groups, and that's really all there is to it. Okay. We were able to do this one without writing them all out. I recognize there's only going to be one group of 5 here. So I took 1A out, but I had 2 left over. I recognized for the B, there was only going to be one group of 5, but I would have had 3 left over. And for the C, there is no groups of 5. Last thing to talk about is just going to be our negatives. And basically it's this. We know that we can do any odd root of a negative. Odd roots of negatives will always give us negative answers. But unfortunately, even roots of negatives are not, you can't do computations with those. Those are not real answers. So we call those imaginary. All right. If you got any questions, bring them to class. Love to help you.